Saxon's Trig, lesson 110, is about the graphs for arcsine, arccosine, arcsecant, arccosecant, arctangent, and arccotangent. And they break that up into sections with 2 in each section. But we know that when we have the word arc, it's telling us to get the degree. So what this means in a graph is I'm basically flipping my x and my y. So before, when we graphed our curves or our u's or our, for tangents, the climb and the fall of the curve, what we were doing was we were putting the degree here on the x line. But since arc means spit out the degree becomes the y line. So that's what you're going to be seeing here. And then your x line is going to do what your y line used to, which was have a high point of 1 and a low point of -1. And that means your graph is basically turning on its side. So I would need to label my 4 sections. Oh, I did not leave myself enough space there to do that, sorry. So like our 90, 180, 270, 360, because each section is in that. So if it is for arcsine, sine starts in the center and it goes up to, so if it's positive, it goes up to the high point first, then down, and then back and returns. So the graph is looking like this, and then obviously repeating as you go down. So if you had flipped this kind of this way, although that's not exact because this looks like it's heading into the negative sections, but it really isn't. But if you picture it, it almost matches, it's reflected, but you get the idea. Okay, so then the graph for arccosine, and I'll try to give myself a little more space. You're still gonna have your 1 and your -1 for your boundaries, and you're going to have your 4 sections. Still didn't do a super great job with spacing. So this is getting to our 360, but our cosine, if it was positive, began at our +1. And the other thing I noticed when I just glanced at the book was that so here it is, they are doing these not in degrees, but in radians. So they're listing this as 2 pi and the others in their pi formats. Now, part B, same thing for arcsecant and cosecant. So when we had our original, so I'm just going to go back to this one, even though it's tight. This was the basic sine curve. And so wherever we had a crossing, we created an asymptote. And we had memorized those for cosecant, opposite of sine, to be at the 180 and 360, and then so my peak is here, and the 0 axis is also acting as one of those. So my curve is here and here, and then basically the sine wave isn't needed, it's just these curved pieces. Now, just a second, I was looking for their range of the arcsecant. Cosecant. Yes, okay. They did this one second in the picture, and I'm used to them doing it first. But you still have, I just want to make sure there's no flipping of the, correct, there is no flipping of the asymptotes. Then this one was the graph of cosine, and so this is going to be your arcsecant. Again, everywhere you were crossing becomes an asymptote. And this one, you can only graph half if you're doing that, if you don't extend it, if you're just doing the main curve, and then the U here. And again, here, you're gonna have, where's the dot? Oh, here, you're gonna have half of your curve, but not the full thing. And then those asymptotes were at the pi/2. Yeah, just verify. So the asymptotes don't change when we flip it. All right, so the final is the graphs for arctangent and cotangent. All right, so for our tangent, high point 1, low point -1, that's still the same. are 1, 2, 3, 4 sections. And for tangent, we know that it started in the center and it fell. Oh, but I need my asymptotes in there. And we memorized those at pi over 2. Okay, so my fall is here. Oh, it's so much harder to draw. So you would actually only have that half if you were doing the thing. And then the curve should be at about the 1 and the -1. Oh, I didn't do too badly. And then this half would just be that part there. Oh, and of course all of those have arrows. We didn't really have that half. And then for our cotangent, same thing. We've got our 1 and our -1. Oh, I guess I should label that cotangent. Arctangent, arccotangent, arcsecant, arccosecant, so I don't cause confusion there. And then the 1, 2, 3, 4, the asymptotes are memorized at 180 to 360. All right, and so from here where it fell, now it's climbing. So I need to climb up. Oh, okay, I'm trying to get my curve at approximately, oh, that was really bad. Curve about there, go through the center, curve should hit about there. It's still kind of bad, but you get the idea that this one is the falling, this one is the climbing. You just have to picture them on their sides there. Example 1 finally is on page 616, and it says, sketch the graph of f of x is the arctangent of x. So they're looking for this graph. State the domain and the range of the function. Oh, we didn't talk about this. So domain are the numbers I put in, and range are the numbers that spit out. So I know that it has to be, oh, let's see, what was that in? Oh, I didn't put these in the graph. Somewhere it needs to label them with a theta or an x, and it's typically up here at the top. So since this is labeled as a theta, I know that it's going to say theta is an element of, and is there any limit to the numbers that you are allowed? Just a second, I want to make sure I'm saying that right. That you are allowed to plug in. Oh, you know what? Clarify one other thing. This one is labeled, so like the x-axis is being labeled x, and this is my degree, so it's being labeled the theta. My domain are the things I'm putting in, so this should say x. X is an element of, and there's no limit to what I'm allowed to plug in, so it is x is an element of the reals. That's my domain. My range should say theta is an element of the reals. It can be anything, but there is a limit here such that, and this is where the memorized asymptotes come in. The theta has to fall between which two, and since it should be in radians, we're going to fill it in radians. Now, this also means where I graph them and I try to mirror them to the originals that I had, for tangent and cotangent, we had a memorized set of asymptotes, but the standard had one of them in the negatives and one of them in the positives, and you do need to stop and memorize which things they want. So even though this pattern continues on and on and on, they are wanting only the basics, which fall between negative pi over 2, has to be more than that, and it has to remain less than the pi over 2. And then you'll need to memorize the opposite with the pi and 2 pi for the cotangent. That should be its boundaries. All right. I'm looking to see why they shifted. There was their domain, there was their range. 0 is an element, yes. Okay. state the domain and range. Oh, that's what I missed. In the directions, it said, then evaluate arctangent of x at x equals -1, 0, and 1. Aha. So when I plugged in -1, it wants to know what was the answer. Where did I land for that? So when I plugged in -1, I got where did that land? This one. That is supposed to be, oh, it's so much harder to do this in radian. I wish they would have just left it in degree. It's -pi/4. Within this boundary of here and here, this one would be dropping to here, and that's -pi/4. When you plug in 0, in that boundary, 0 was at 0. That one's at least nice. And then when you plug in 1, within that boundary, you went up to the pi/4. And that's the 3 answers they're looking for plugging those in.